It's Flashcards Friday, and today we are going to break down the science you already use, even if you've never thought twice about it. I'm Gabrielle Burchak, and today we are talking about everyday physics, not the chalkboard covered in equations kind. I'm talking about the physics you live with, walk with, drink coffee in, and scroll your phone with. You use physics all day long. You just don't see it. But after this episode, you will. But first, a word from my advertisers. Let's start with something so basic you probably haven't thought about it since you were a toddler. Walking. Walking is a constant dance with gravity. You lean forward just enough to start tipping, but not enough to fall. Then your foot catches you. One leg swings forward like a pendulum, while the other pushes off. Physics calls this inverted pendulum model of walking. It's not just gravity at play either. Friction between your shoes and the ground keeps you from slipping. That is Newton's third law. Every action has an equal and opposite reaction. Your foot pushes back, the ground pushes you forward. If you've ever tried to walk on ice, you've felt what happens when friction leaves the chat. Suddenly, you are a physics demonstration in motion, sliding around, unable to stop, and reminded just how much physics normally works in your favor. Okay, let's move on to the next one. You're walking. Let's say you're holding a cup of coffee. Oh, wait, speaking of coffee, don't forget to visit me at mathsciencehistory.com and click on that coffee image and make a donation to Math Science History. It's an educational podcast, and every donation you make keeps it going. Anyhow, back to walking with coffee. Here's a weird thing. If you've ever noticed, it's easier to spill your coffee when it's filled to the brim than when it's only half full. Why is that? Well, that is physics again. Specifically, it's about something called resonance. As you walk, the coffee moves back and forth. If your steps match the natural frequency of the liquid's slosh, the waves build up and splash over. This is called mechanical resonance. Same idea as when a swing gets higher if you push it at just the right moment. That's what you're doing to your coffee without realizing it. But we naturally and unconsciously adjust our gait to avoid it. You slow down or stiffen your arm to minimize the slosh. Your brain doesn't do the math, but your body's been trained by spilled coffee to solve the problem right away. Now on to smartphones, our pocket-sized physics labs. Okay, let's jump into your pocket or your hand. Let's be real, it's always in your hand, right? Your phone is packed with physics. First, there's the accelerometer. That's how your phone knows if you turn it sideways. It measures acceleration and orientation based on changes in electrical charge when tiny components inside the chip shift. Those changes are physical, caused by movement and gravity. Then there's the touch screen. Capacitive touch screens detect changes in the electrical field on the screen's surface when your finger, a conductor, makes contact. It's not magic. It's electric fields, conductivity, and charge redistribution. And that always happens in my purse too. I hate it. It turns on even though I don't want it to. Okay, even your signal, Wi-Fi, Bluetooth, mobile data, it's all electromagnetic radiation. It's physics. You are sending and receiving invisible waves through the air every second. Maxwell's equations in your palm. Think about that. Isn't that cool? Okay, now let's turn on the faucet and talk about torque in action. Let's say you turn on the tap, or even maybe twist a doorknob. You use a wrench, right? Okay, so every time you apply force to something that rotates, you are using torque. Torque is rotational force. The farther you are from the pivot point, the more torque you generate with the same effort. That's why faucet handles are long and why we use wrenches with long handles to loosen tight bolts. Without torque, mechanical advantage doesn't exist. You'd be stuck applying brute force to everything. Physics gives you the shortcut. All right, now let's look in a mirror. Sometimes it's not something I want to do, but I'm forced to do it because there are mirrors everywhere. You see yourself because light reflects off your face, hits the mirror, and bounces back into your eyes. That's the law of reflection. Angle in equals angle out. Your brain then interprets those rays as if they come from behind the mirror, giving you a perfect, albeit reversed, image of yourself. And that is basic optics. Your brain does it in milliseconds, constantly interpreting light paths, depth, and angles. Have you ever looked into a spoon? Try it. You'll see your face upside down. That's curved mirror physics, and it's because of how convex and concave surfaces bend light rays differently. Okay, now we're going to stop walking and looking in mirrors and carrying containers of coffee. We're going to drive. All right, when you hit the gas in a car, you feel yourself pushed back into the seat. That's Newton's first law. Objects at rest stay at rest unless acted on by a force. The car accelerates. You don't, well, kind of, but you don't really accelerate until the seat pushes you forward. That's why I always say that we are accelerometers. The force from the engine moves the wheels, friction with the road moves the car, and your body gets carried along for the ride, and we can feel the acceleration. When you hit the brakes, the opposite happens. Your body wants to keep moving forward, and that's why seatbelts exist. They apply the force needed to stop you from obeying physics too well. Even turning is physics. Centripetal force pulls you toward the center of the curve, and inertia tries to fling you outward. That's why you feel pushed to the side during sharp turns. Okay, now we're gonna go home. We're gonna make some dinner. Let's boil some water and melt some butter and toast some bread. All of this is heat transfer. Thermodynamics shows up big in the kitchen. Heat moves from the stove to the pan to the food. That transfer can happen in 3 different ways: conduction, convection, and radiation. Conduction is direct contact. Convection is fluid motion, like boiling water or air in an oven, like the air fryer on your French fries. And radiation, like a broiler or a microwave. Do you ever notice that water never gets hotter than 100 degrees Celsius when boiling? That's the boiling point until all the water is gone. Extra heat just speeds up the transition from liquid to gas. Understanding even the basics of heat helps you cook better, faster, and smarter. Physics, it's your secret sous chef. Okay, right now I'm talking. You're hearing my voice and my laugh. Oh my God, what's happening? Well, sound is just waves of air pressure. My vocal cords vibrate, pushing air in patterned waves. Those waves travel through the air, hit your eardrums, and get converted into electrical signals in your brain. The pitch, that's the frequency of the wave. The volume, well, that's amplitude. If you've ever cupped your hands around your mouth to shout, you've manually created a directional speaker, funneling more sound energy in one direction. It's more physics, intuitively applied. Okay, so you've just eaten your dinner and now you gotta go use the restroom. You run to the bathroom and your door swings open. Do you ever wonder why doors have hinges where they do? Have you noticed that door handles are usually far from the hinge? That's leverage. The longer the distance from the pivot point, which is the hinge, the less force you need to apply to open the door. Same reason we use crowbars and pry bars. It's torque again, and designers build this into everyday objects to make life easier without you needing to do any calculations. It's physics by design. Okay, let's toss a ball, or toss your keys, or even flick something off your desk. Everything you throw follows a curve. It's called a parabola. That is projectile motion. Gravity pulls it downward while your initial force sends it upward. These two motions combine to make an arc. Your brain is a pro at predicting these arcs. It is, even if you've never studied kinematics. That's how you catch a ball. Your brain does the math, whether you know it or not. Yeah, You are a mathematician. You are a physicist. You don't even know it. So, what are the takeaways? What are the 3 flashcards today? Well, you don't have to know physics to use it. You already do. From walking to texting, your body and your brain are constantly applying physics principles without asking for permission. 2, the world is built to work with physics, and so are you. Faucet handles, door hinges, cars, even coffee cups are designed with physics in mind to make life easier. You are surrounded by smart engineering, even in the simplest stuff. You are a smart engineer. Our bodies were made for this. And now the 3rd flashcard. Paying attention to the physics around you can make your life better. Understanding just a little can help you avoid spills, drive safer, cook smarter, and maybe even impress your friends with how much you know how things work. So, you don't need a lab coat, goggles, or a PhD to use physics. You already do, all day, every day, walking, driving, cooking, turning knobs, tapping your phone, tossing a pen. Physics isn't just some subject in school. It is the rule book that makes the world tick. You are a player in the game, whether you know the rules or not. And I don't know about you, but sometimes I forget the rules because I trip and fall. But technically, now you know a few more. And I do too. Thank you for listening to Math, Science, History. And if you enjoyed this episode, drop us a rating, share it with a friend, and subscribe for more bite-sized science that connects with real life. And until next time, carpe diem.